Pre-calculus. Today we'll be discussing matrix multiplication. The matrix, you remember, is just a table of numbers. One big advantage to using matrix algebra is that we can think of huge arrays of numbers, such as a data set in statistics or the pixels on the screen of your favorite video game, as a single entity. In fact, the best video games can manipulate these blocks of numbers simply and efficiently and make the game more interesting and realistic. Of course, in between video games, you may consider making a little money and moving out on your own. To that end, you should know matrices are used extensively in successful businesses. In fact, organized and efficient are necessary for businesses to succeed, and matrices provide businesses with a tool to help organize data. For instance, the Cuddly Toy Company manufactures 3 types of stuffed animals: pandas, kangaroos, and rabbits. The production of each toy requires cutting materials, sewing, and finishing. This matrix shows the number of hours of each type of labor required for each type of toy. Please pause the video now and give me your best answer to these 3 questions. Okay, the number of hours needed for cutting for a rabbit would just be the intersection of our cutting row and our rabbit column in 0.4 hours. We need the number of minutes for sewing a panda, so that's going to be 0.8 times 60, or in other words, 48 minutes. And the total number of hours for 2 pandas, let's see. If I add up all the time for the pandas, cutting, sewing, and finishing, that'll be 1.9 hours. And I multiply that by 2, and I'll get 3.8 hours. Now let's take a look at the second matrix you'll need in today's lesson. This company has received orders for the months of October and November. This matrix shows the number of each type of toy to be produced each month. Please pause the video now and give me your best answer to these 3 questions. The number of kangaroos produced in November is just the intersection of this row and column. The total number of rabbits produced in October and November would be these 2 items added together, 1525. And the number of toys produced in October would just be the sum of these 3 items, which would be 2,400. Okay, now let's see if we can get some new information from combining these 2 matrices we saw at the beginning of the lesson. It's completely realistic that the company would want to know how many hours are spent on a certain part or a certain type of labor. So the company here needs to know how many hours are spent cutting in October. Please pause the video now and come up with an answer to these 4 questions. So, pandas take a half hour to cut, and there's 1,000 of them. So a half an hour times 1,000 is going to get me 500 hours just cutting pandas. Let's see. Kangaroos need 0.8 hours to cut. There's 600 of them, 480 hours. And then rabbits, 0.4 hours, and there's 800 of them. And that gives me 320 hours for a grand total in October of 1,300 hours just cutting stuffed animals in October. Now let's talk about the time spent sewing in the same month. Please pause the video now and give me your best answer to these 4 questions. Pandas. It takes 0.8 of an hour to sew a panda, and in October we need 1,000, so 0.8 times 1,000. It takes an hour to sew a kangaroo. We need 600 of them, and it takes a half an hour to sew a rabbit. We need 800 of them. And the grand total of hours spent sewing in the month of October would be 1800. Now that you've got the rhythm of this and the pattern, let's just look at the one row in the first matrix we'll need and the one column in the second matrix you'll need. On your own, I'd like you to multiply the finished row of the first matrix times the October column of the second matrix. Pause the video now and start it again when you have an answer. I'm sure you have the pattern of this down now. We're going to take the first element of the first matrix times the first element of the second matrix, the second times the second, and the third times the third. We're going to add those products together, though, and pandas and kangaroos and rabbits, and get a grand total of 1,240 hours spent finishing each stuffed animal. And that's it. Let's finish this up. Here's your question. I need you to calculate for me the total number of hours spent cutting, sewing, and finishing in the months of October and November. Please pause the video now and complete the matrix at the bottom of your screen. First, we'll fill in the October numbers, and then I'd like you to focus on the first row of the first matrix and the last column. Now, I have this little animation I'd like you to watch. Imagine taking the first row, I'm going to turn it on its side and put it right next to the last column. So those are the pairs of numbers I'm going to multiply together and then add the products together. In this example, 0.5 is 1100 plus 0.8 times 850 plus 0.4 times 725, giving me a grand total of 1,520. So the next thing is the sewing in November. I'm going to try to picture taking that row and twisting it and moving it over to that column. So that gives me my pairs of numbers to multiply and then add the products. The number of hours spent sewing in November, the grand total then would turn out to be 2,092.5 hours. Last row times the November column. Try to picture that in your mind as you do this multiplication. So the last row times the last column is going to give me a grand total of 1,362.5 hours. Now I can complete my what's called labor by month matrix. And now the company can make some decisions. For instance, the number of hours we're paying for sewing in November. That's a big ticket item. If we could cut back on that a little bit, well, we'd be saving some money. And on a purely mathematical side, the process you have just completed is called matrix multiplication. You know, one of the earliest applications of algebra occurred in the 1920s when Werner Heisenberg investigated matrix mechanics and made it a part of quantum theory. In other words, matrices existed for 2,000 years before we were smart enough to try to solve mysteries that needed them. And so from an applied perspective, matrix theory was very much a solution looking for a problem. Here endeth the lesson. Thank you for your time and attention.